right, good evening, guys. We're going to be doing an overview today of the entity relationship diagram itself. We were covering entities overall and relationships during the last class, but now we also want to expand on the different types of attributes that are available. I'm going to start by doing an overview of the material so far, and essentially just cover in a relatively brief period all of the different elements that we need for an entity relationship diagram. We'll go back to the class on Wednesday, answer any questions you might have. Then we're going to be moving on to an expansion for the entity relationship diagrams called the pertinently enhanced entity relationship diagram, which allows us to do categorization. And we'll continue with that topic during the next week. So without further ado, let's just start this. All right. So let's start with the review. This is a summary file. You can open in draw.io. It is already located in Canvas. You can open it on using draw.io. The file, as you download it, if you try to double click it and open it right away, it will take you to the browser, unless you have draw.io installed on your machine. The correct way to actually open it up will be to go into draw.io in the website, then click open file from my device, and then look for the file. Otherwise, it's not going to open properly. So having said that, in this file, what we have is 4 different tabs. Basic cardinalities for relationships, theories of the relationship, that essentially covers how many entities can be connected in one relationship, other types of entities that we might want to explore, and the attributes. So let's go back to the basics. When we're talking about entity relationship diagrams, we were talking about models that included entities that represents categories of interest for the organization. These are events that are happening that require us to review changes, to record changes in the data as they're happening. So if we perform a sale, then we need to decrease our inventory. If we perform a sale, we also need to increase our revenue because we are charging something to the customer. We also want to get the data about the products that we're selling, customers that we're attending, any category that we believe is relevant for the final user to support their operational activity. We want to keep it and represent it in a virtual manner in the form of an entity. These entities show a relationship between them, which we call cardinalities. The cardinality specifically refers to how instances of an entity relate to instances of an entity. That is, if we have an entity that is a student, that's a general entity type, a general category, and an entity instance will be an individual student. So cardinality will be how one student relates to one or multiple of any other entity that is related to the student. So one student relates to, let's say, one or multiple classes, just to provide an example. They go both ways. So we typically explore the relationship by adding a line between the entities, but we need to explore them in both directions by essentially making a short sentence with this structure. How one instance of the first entity, let's say entity A, relates to one or multiple instances of entity B. So, and then backwards, how one instance of entity B relates to one or multiple instances of entity A. The basic cardinalities are going to be indicating the maximum amount of connections that there can be. So these are typically summarized as one-to-one or one-to-many. One-to-one were those relationships where one instance of the first entity can relate to one and only one instance of the second entity. So for example, if we are dealing with students on campus, you might only be able to enroll one vehicle in your parking permit. Perhaps, just an hypothetical scenario. If that is the case, then the relationship is one-to-one. One employee can only enroll one and only one vehicle in the parking pass. But if there is a possibility of one employee enrolling more than one, then we switch to one-to-many. And we will say something like an employee can register one or multiple vehicles in the parking permit. And when we have a one-to-one, we use a line with a perpendicular line crossing it over to indicate that relationship, that is maximum one connection. If we have a one-to-many, we typically do so with a line with a crossfit at the end, suggesting that there is more than one possible connection. So in this case, a customer can place one or multiple orders. That's going to be our relationship going in that way. If we wanted to examine it backwards, we might want to say something like, well, an order can be placed by only one customer. If we wanted to do that, we will click on the line, then on the icon for type of line, and we will do the one side. So a customer can place one or multiple orders, but an order can be placed by only one customer. So we want to do it in this format. If we have something like a situation where the relationship is one-to-many in both sides, both directions, then we typically want to recreate that as a new type of entity that captures the matches between them. That is, if a customer can use one or multiple products and a product can be used by one or multiple customers, we have a one-to-many in both directions. So one customer can use one or multiple products. A product can be used by one or multiple customers. It's two relationships in essence, but we can overlap them as a single line and just show it as two cross-fit in both sides. We call that a many-to-many relationship. It's a nice way of summarizing it. If we have a situation like this, it will essentially say that one instance of a customer can use one or multiple products, and a product can be used by one or multiple customers. In other words, we can have any sort of combination between the two tables or the two entities, and it will be okay. These are typically going to require us, they can be expressed like this just fine, but they are typically going to require us to store data about how the relationships are done in a new table. So they're typically going to be recreated as a one-to-many, not going from the customer towards the product, but going from the customer towards a new table in between. And then a one-to-many, not going from the product towards the customer, but from a product to a new table in between. So we can use the new table to do some type of analysis. For example, if a customer can buy one or multiple products, say this is buy, and a product can be bought by one or multiple customers, that is because the category of that product can be used by multiple customers, then we actually might have a situation where what we are seeing is that there are orders happening in between. And what we want to capture then is not so much that one customer buys one-to-many products or one product is bought by one or many customers, but instead we might want to have something like a customer can place one or multiple orders, which therefore allows the customer to buy one or multiple products. And a product can be bought in one or multiple orders, which allows therefore to be bought by one or multiple customers. So this can actually just be an order table in between another entity. So as a rule of thumb, these many-to-manys can easily be translated into two one-to-manys connecting to a table in between or entity in between. If we have this, we call this an associative entity. It's just an entity whose purpose is to capture the matches or association between two other entities. There can be things like the time the order happened that we want to capture there and doesn't really fit well in either of the other two entities. So we still want to have it there. So those are essentially our main tools. We have one-to-one relationships, one-to-many relationships. We have many-to-many. And if we have a many-to-many, we can easily translate it into two one-to-manys to simplify our lives and provide further meaning to the relationship. But that is only talking about the maximum number of connections, saying the maximum is one or the maximum is potentially infinite. We can also specify the minimum by using what we call optional or mandatory relationships. So we specify that with a second symbol. That is this little circle that you see closer to the middle of the line. That is saying that the relationship is optional. Or in other words, there doesn't have to be a connection between these two tables, which means that in this case, a customer can place 0 orders or no orders, or that's a minimum 0, or they can place at most 1 order. That's a perpendicular line here. Or we could also say with a many type of relationship, like here. A customer can buy no products, so a customer hasn't bought anything, or they can buy 1 or multiple products. That's the CrossFit. So it is possible to set up both a minimum boundary and a maximum boundary using these two symbols. The symbol for the optional is that little circle right there. It always goes further towards the middle of the line, no matter which direction you are doing it. So if it was a customer can place, let's rephrase this, a customer can place 1 or multiple orders. I'm just going to change it like this. And we were also saying that an order can only be placed by only one customer. We could say, let's use this symbol for now. We could put it in both sides. Doesn't matter which side we are using it. The symbol for the optional or mandatory always goes more towards the middle. And the symbol for the maximum cardinality goes more towards the end of the relationships. So the circle is the optional symbol. For mandatory, it's going to be another perpendicular line. So in this case, a customer can place at least 1 order and at most 1 order. So it has to be exactly 1 order. There cannot be a customer that has not placed an order. There cannot be a customer that has placed 2 orders based on this scenario. And we can do the same type of specification on the other way around. So let's make this a little bit more meaningful for practice. In practice, you will expect that a customer may or may not place an order, but they can place many. So I'm going to change this to an optional many. There. And we could say that an order, for it to exist, has to have a customer. And we only associate an order to one single customer at a time. So this side, we could say that it's a mandatory one. So we can change it. There it is. And that gives us a lot more details about what is happening here. The relationship is optional from the customer towards the order, but mandatory from the order towards the customer. All right. And we can also further expand this by using numbers. We can add a text and just establish the number of connections that we want. So let's say we don't want to say that it's just mandatory and that's it. We want to say that it's mandatory and the minimum number of connections is 2. Well, we can put a 2 next to the symbol. We can do so as well for the mandatory side in here. Just try to position in a way that it's legible. An approach that is often used is to, for example, let me recreate this one. Do something like maximum 5 ... and number 2. This is actually more often used in class diagrams because it's a proper class diagram notation. For anyone that has taken system analysis and design, you'll notice that class diagrams and entity relationship diagrams are 95% the same. So you can always use this notation in here. For those of you that haven't taken it, then as a heads up, once you're doing system analysis and design, you're going to see this type of notation often. But it's simply saying, what's our maximum, ... what's our minimum? Or if you want to just have one number, let's say the minimum. Well, it wouldn't make sense to have a 2 and then maximum 1 in here. So let's make it something more meaningful. Like that. That's way more meaningful. We want to use these symbols. Don't override these symbols with anything else, even if you're familiar with class diagrams. The crossfit and the perpendicular line, that's what we want to use. There exist some alternatives for class diagrams. And while it is very common for people to overlap it, they are not the same and they shouldn't be used as the same thing. So for example, entity relationship diagram. Let me just show you how common this error is. Entity relationship diagram. If you go into this model, this is fine. These are good notation. If you go to this one, ooh, look at that. That is actually a class diagram notation. It says the same thing, but this is only relevant for anyone that has taken systems analysis. If you haven't, just don't worry about it. Just keep trying like this. If you have, this says the same thing, but it's not the proper language for the context in which we're using it. So try not to mix them up. For the class assignments, definitely don't mix them up. For practice, once you're in the work environment, see what everyone else is doing. Most likely than not, anyone that can read a class diagram will be able to read an entity relation diagram and vice versa. So it will be common for you to have to mix and match. And you might also see this approach. That's a different way of identifying the entities and the attributes. And this is perfectly good. An entity relationship diagram is just a different approach for an entity relationship diagram. So this is also perfectly valid. You might see those more like towards the engineering side of things. All right. So that's about it for that. We have several examples here. We have discussed this in the class. So I'm going to skip them for now. I'm just going to go into the degrees themselves. So for any type of relationship that we can have multiple different types of degrees. Degrees are just how many entities we have in one single relationship. The most common scenario is 2. That's what we were seeing before. And that's called a binary relationship, but it's not the only type. You can have 3 entities connected to each other. You can have 4 entities. You can have more than that. It doesn't matter how many we have. The same principles for cardinalities and how to set up relationships and the attributes, they all apply the same. If you have something like this, it is pretty common for it to be replaced with an associative entity. We'll talk about that in a little bit, but that's the general idea. You can use this if you want. Perfectly good for the entity relationship diagram. The one that I want to pay attention to because it leads to more confusion sometimes is the unary. That is, entities in instances in one entity relate to other instances in the same entity. So that's going to be very useful if you want to explore how 2 different things or 2 different individuals or products or any other 2 instances of one entity are related to each other. The approach for the cardinality is the same. You still have 2 directions to go to. So how the first instance relates to the second one, and therefore how the second one relates to the first one. So you can have one-to-one, you can have one-to-one mandatory, one-to-one optional, one-to-many mandatory, one-to-many optional. You can have many-to-many. All right, pretty much the same. Just focus on the instances themselves. In other words, if we were looking at our model here, what we will be looking at is kind of a table. Essentially, one row can be associated with a second row, and therefore the second row can be associated with the first one. Like a person 1 could be the manager of person 2, could also be the manager of person 3, could also be the manager of person 5. But it turns out that person 5 is the manager of just person 1. In that way, we have a relationship in which a person is managed by only one person. Notice from 2, there's only one manager. From 3, there's only one manager. From 5, there's only one manager. From 1, there's only one manager. But a manager can manage multiple individuals. Person 1 manages 3. Person 5 manages 1. So this essentially is a one-to-many relationship between 2 instances of the same entity. We could recreate this as this. Notice that 4 doesn't have a manager and doesn't manage anyone. That makes it optional on both sides. That will be a relationship, in this case for an employee entity. All right, so that's the logic behind those. Now, notice here we have the many-to-many relationship with unary. That means that there's going to be a lot of information there that we might want to gather. If we had that, that's the most common example, could be something like a marriage or marriage. No, marriage would be one-to-one. Let's say we can have a product being used in a different product. That's one of the examples that we have in the class. In the labs, we could also have a book. This is one of the examples that we have in the class. In the lab, we have a book table in which every single instance is a different book. Well, and a book could be an anthology. And what is an anthology? Just an aggregation of multiple different stories within the same book. So by themselves, each one of those stories could be a book. Like every book in the Harry Potter series is an individual book, but you could have an anthology that gets all of the books into one single presentation, right? Published collection of poems or a piece of writing. So it could be just aggregation of all of different Harry Potter books in one single book. So what can happen there? Well, a book could be contained in one of those anthologies. An anthology itself could also be contained in a different anthology. So we can have, let's say, book 1 and 2 are Harry Potter's book, Harry Potter 1, Harry Potter 2, and this is the Harry Potter anthology. If we do it this way, then the Harry Potter anthology contains Harry Potter 1. It also contains Harry Potter 2. All good so far. But what happens if we release the anthology when we have done the first 2 books? Then we continue, the publication period continues, more books are published, HP3, Harry Potter 4, and then we release a second anthology to aggregate everything that we have. Well, the second anthology could actually contain the first anthology plus the two new books. And what happens then? It becomes a situation where one anthology could contain a different anthology within itself. So we kind of need to treat this differently. We need to be able to make an association of which books belongs where. So a common way of handling this is to essentially create a new table on the site that will just record the book see if we can zoom this out or just move it a little bit. Slowly but surely we'll get there. All right, that should be enough. Let's make this big. All right, so this is our main book. This could be what we are going to be consider. Let's rename that into something meaningful. We can use any name that we want. I'm going to make a name that is really descriptive. Oops. Book that is contained in other book. So this is a column for the book that is going to be contained in the other book. And And this is going to be the book that contains other books within itself. We can typically make something like this to simplify things. Why? Because it will let us make a record of the matches. So we can refer to the book ID, this number, in either of the two sites. This book ID can be in either of these two. How? Well, we can say that Harry Potter 1 is contained in book 3, which is anthology. Harry Potter 2 is contained in book 3, which is anthology. Harry Potter 3 is contained in, oops, Harry Potter 3 is actually number 4. Harry Potter 3, which is ID number 4, is contained within the anthology 6, this one right here. And Harry Potter 4, which is number 5, is also in the anthology. But also the previous anthology that we have mentioned here is, and it's here, right here, is also contained in anthology 6. Making a new entity for matchups when we have a many-to-many can help us really give it nuance, a lot of detail to the information that we're gathering. So it's a very common practice. We call these entities associative entities. So let's go back to the slide, to the raw audio file, and let's look at the descriptions. Right. Apart from associative entity, we have something else that we need to capture, which is attributes of a relationship. So we can have some customers placing orders, and an order being placed by only one customer. But what happens if we want to put a reservation date or some other factor like that? Well, if we want to do something like that, then that attribute is not actually about the order alone. It's about the customer making the reservation for a given order. So it's not just about the order, it's about the order and the customer that pay for the reservation. It's not also just about the customer, it's about the customer and the reservation that they are placing. So it's about both of them. That is, the attribute wouldn't fit neatly. The attribute of when the reservation was made wouldn't fit neatly in either the customer entity nor the order entity. So what we do in those cases is just to draw a dotted line between the attribute name and the line that represents the relationship to say this date of reservation is an attribute about the relationship between customer and order in this case. We can do that for any attribute that seems to be about their interaction between two entities. So both the associative attributes and associative entities like this one can help us get extra information about the matchups between two entities. So when do we use one or the other? We will use the associative attribute if it is something simple or every single attribute that we're interested in capturing is different from each other. We will use the entity if the things that we're trying to save have importance, a high level of importance for the organization. Like it's a key thing to keep track of. If we were looking at the customer and the products, like we did in one of the previous examples, identifying the orders is important. We only earn money by looking at the orders. It's how we operate. If we look at the books and the books in which they belong, it might be an important characteristic. If we want to look at, in this case, employees completing one or multiple courses and getting certifications for them, and courses being offered to one or multiple employees and assigning certifications for those, well, we could add the certificate ID as an attribute for the relationship. But if we wanted to get further information, we could like when it happened, what's the topic, what's the GPA, and now we have like a list of related attributes. We might want to, rather than having a series of attributes on the top, just making an entity on its own. So in summary, we want to add associative entities whenever we have a man-to-man relationship, whenever we have attributes of the relationship, and there are several of those, and they are either meaningful to us or like meaningful to the level that we want to really focus on capturing them, or um, they are all cohesive about the topic that they're covering. They all dealing with the same stuff. Finally, if we have something like a ternary or inary, like if the degree of the relationship is really high, we can always just put an associative entity in between and simplify this so that instead of having a relationship with four entities, we can have four binary relationships in which all of them relate to just one other entity that will be here in the middle. That new entity will record the matchup of all of them. It will say, oh, this is an event in which A interacted with D, interacted with B, interacted with C at this time, and this happened. So it is possible to use in any of those circumstances. The other type of entity is a weak entity. So that's the last one of the entity types. Notice it's shown completely different from the others. It has a double line around the entity box. It has a double line around the relationship. So what it's trying to say is that we are capturing information about a thing of interest that is related to something else that we are interested in. What makes it unique is that by identifying as a weak entity, we are saying we are only capturing this information for as long as there is data related to it. So if we have customer data in here and we have, well, let's simplify with some campus related thing. If we have a student's data in here and we have the vehicles that they are driving and we want to register them for on-campus use, we definitely need the student information. We are a school. That's what we store. That's our main thing. The vehicles that they are using, not so much. We just need it because we need to vet the cars and just take away or find those that are not supposed to be here. So we might choose a rule that we will only keep the vehicle information for as long as there is a student associated with that vehicle. That's what the double line would say. That's what the weak entity itself means. So what does that mean? It means that if we have 100 vehicles enrolled at a given time, let's say this semester in the campus, the semester ends, 50 students graduate. We need to eliminate the 50 vehicles associated with those 50 students because they are no longer going to be on campus and that data is no longer necessary for us. So because the student data associated with the vehicle data is gone, the vehicle data will be removed as well. That's the point with the weak entity. The records in the weak entity only exist for as long as they are related to some other entity. If the relationship is broken for whatever reason, that is also gone. That's pretty much a rule that we set up to control how everything is operated, and we can specify it with this double line. So those are the entity types that we need to pay attention to. Weak entities, associative attributes, and associative entities. The only other entity type is a strong entity. And a strong entity is just an entity whose values can exist even if they are not associated with anything else. It's really any other entity that we were dealing with. All of these entities are strong entities, which is why I didn't put a separate box for them. But just know that's what they're called. And the last thing that we needed to cover was the attributes themselves. So attributes, we've been using them already in the class, but we really haven't gone deeply into the types that can be included. The main types where you just type in the name and you have a single value per cell, they're called simple attributes. It's just for that cell, you have one single piece of information. That information could be text, numbers, a Boolean value, could be anything, but it's just one. If you have more than one, you're either going to have a composite attribute or a multi-value attribute. These are the two options for having more than one piece of data in one single cell, one single attribute for a row. These two are different in how strict they are for the records that are available. So composite attributes have a structure. Yes, there's more than one piece of data for every single attribute, but they are predefined. For example, if we have an address, we could set up the address attribute as being composed of 5 different things, and you will always have those 5 things. Those could be a street name, avenue, zip code, city, and state, just to provide some examples. There are more than one piece of data, but they're always the same elements. So they're predictable. The opposite of that is going to be a multi-value attribute. It also allows multiple pieces of data in one single attribute, but there is not going to be a predefined structure. So there could be no values for one row. There could be one value for a different row. There could be 20 values for the third row. It doesn't matter. There is no predefined structure to it. A good example of that is a skill. We can have employees say that they have no reported skills. They will have a skill that is going to be just they are great at public speaking. Another employee can come and say, oh, they're good at Python programming, SQL programming, using databases, designing, math, physics, whatever it might be, and just list a huge list of attributes, so, a huge list of skills. So that would be valid for multi-value because it can be any option. We differentiate them with the symbols that we use. Multi-values, we use these curly brackets that tells you this attribute is a curly bracket. Just put the attribute name within the curly brackets. And if you have a composite, you list the name of the attribute. Oh, there is customer address in here. And then follow with parentheses and the components separated by commas inside. So customer address is composed of a street name, address, city, state, postal code in this example. Those are essentially the examples for multiple values. Apart from that, we can also have derived attributes, which is just a calculation. They're not stored in the database, but we might have something like a date of birth of a student. And we might want to have an attribute that says the age. Instead of storing the age as a separate value, we can just list an attribute that is going to be calculated on the fly. Every time someone wants to know the age of the student, the system will go, pick up the date of birth, and then subtract the current date, and it will give them the age. We identify that it's calculated because it has square brackets and the name of the attribute inside. Those are the different types of attributes. The only other thing to consider for attribute types is going to be the IDs. So IDs can be simple attributes or composite attributes. IDs are attributes whose value can uniquely identify an instance of an entity. Beach ID for students, social security number, credit card, phone number, probably. A great attribute will be one that cannot be changed or lost by a user, that is not private information, so we can actually use it readily without worrying about security. So social security is probably not a good one. Well, definitely not a good one because it's too sensitive. Is phone number, probably not a good one because people can change it. Email address, probably not a good one because people can lose it. But they are potentially IDs because they do serve the role of uniquely identifying a person. Something like a beach ID is not going to be lost. If a person forgets it, they can always figure it out again. It's not going to be transferable. It's not really private information per se, because it's really for the purpose of the school, only for the school. So it's probably a great one to have. So just make an assessment of what you want. Okay, so I mentioned IDs can be simple or composite. Simple, all of the ones that we mentioned before are simple. Just one piece of data and you identify the person. Sometimes you want to identify an instance with more than one record. For example, the flight. We can identify flights not just with one ID number, but a composite of things. Flights are typically identified with something like, I think we use A2526 last time. Here. A code like this. Typically, it's going to be some letters at the beginning, that tell you which airline we are dealing with. In this case, AA is American Airlines. Is it enough to uniquely identify a flight? No, there's plenty of flights for American Airlines. Then an ID that tells you the route that is being taken. In this case, 2526 is to go from Miami to Tampa, at least at this time. Looks like there's two options. It's actually Miami to Tampa or Tampa to Miami. So is it enough to identify it? No. Is the combination of AA 2526 enough to identify the flight? No. The most you could do is identify that it's American Airlines between Miami and Tampa. We don't know the direction. And it happens every single day. Like tomorrow there will be one. Today there was one. Actually, that's tomorrow. Today there was one. Yesterday there were two. You cannot really identify it like that. But if we combine the airline ID, we know that this is the one from American Airlines. We combine the route number. We know that this is the route that is being taken by American Airlines. And then we combine it with the date and perhaps the time, we can get to it. So if it is AA 2526 and it is for today, we are limited now to two options. If we combine those two with the time, 140, now we definitely have one. So we can narrow down the combination to a level that we can uniquely identify an instance. In this case, for the flight would be the airline code, the route code, the date, and the time. With those four elements, you have identified the specific flight. How do you do it? Attribute name, parentheses, and the components, just like a regular composite attribute. So those are the options. We're going to be doing some exercises once we come back on Wednesday. So I'll try to keep this as short as possible and see you guys on Wednesday. Have a great day. Bye-bye.